Okay, let's jump right into this test review for test number 2. It's going to cover sections in the text 11.4 all the way to 12.6. Remember, we did skip 12.4, so that won't be in here. I've broken it up into two sort of segments, and you'll see that in Canvas. So right now, let's go ahead and take a look at 11.4, which is the chain rule, right? Chain rule. So just a quick review of what the chain rule is that basically we have a function inside of a function. So we've got a composite function. I don't really like the letters they use, but that's what we've got. So it's a function, the function u inside of the function f. And so what we end up doing is we take the derivative of the outside function, notice the inside function still sitting there, and then take the derivative of the inside function. We'll work through a few examples as we've done. So basically it's the derivative of f with the expression, some sort of function, something more complicated than x, let's put it that way. It's the derivative of the outside part of the function itself with that expression still there, multiplied by, so there's a times here, multiplied by the derivative of that expression. Okay, so let's go ahead and do a few examples and keep moving forward. So the first one is to find the derivative of this function, which they're calling y. You could call it f of x if you want, but we could use this prime notation. We're going to take this derivative. What we notice is that there is an inside part. Now, the parentheses is usually going to signify an inside part with an outside part. So this is like some function, say u to the 5th power. So what we do first, we take the derivative of the outside part. This 0.4 is a constant multiplier, so it just tags along for the ride. The 5 comes down into the front, and notice this parentheses is just not going to get touched. It's protected. So we multiply by 5 because that's the exponent coming down in front. We have the expression 3x squared plus 2x minus 8. Nothing has happened to it yet. And then we subtract 1 from this exponent. I'm going to do that. That's how we take a derivative, right? So we've got the outside function, the derivative of the outside function. Now what we need to do is go inside and take its derivative. So and then we're multiplying by the derivative of the inside function. Okay, so what's the inside function's derivative? Well, we look here. 2 comes down, multiplies times the 3, so that gives us, I'll go ahead and do it step by step. 3 times 2, the exponent coming down, and then we get 2 minus 1. That's that derivative. This one has an exponent of 1, so it's plus 2 times 1, x to the 1 minus 1. And then the derivative of a constant, negative 8, that's going to be 0. I'll just put that plus 0. So that's the derivative of the inside. So notice we have really not done anything new except in the organization, taking the derivative of something on the outside and then multiplying by the derivative of the inside. So we get our final answer. 0.4 times 5 is 2. We get 3x squared plus 2x minus 8 to the 4th power, okay, 5 minus 1, times 3 times 2 is 6, 2 minus 1 is 1, so it's 6x, and then plus 2 times 1 is 2, and 1 minus 1 is 0, so the x to the 0 is 1, plus 0, so this is all that's left. Okay, that's our chain rule derivative. Okay, and we take a peek, we won't look too far. That's exactly what they've got down here for our answer. For this one, the next one, the B question, as we go to take its derivative, what we want to do is notice there's an inside part, and what's the outside part? It's really a 1/2 power. A square root is a 1/2 power. So we're going to take the derivative of the outside part times the derivative of the inside part. So y prime, the 1/2 comes down in front, so we have 1/2 x to the third minus 50x. 1/2, I'll do that over here so we can kind of clean it. We take 1/2, we subtract 1 from it. Let's subtract it as 2 over 2, so that's a negative 1 over 2. Negative 1/2. Nothing's happened to the inside. Now is the time to deal with the inside part. So the derivative of the inside part, the 3 comes down. We get 3x squared minus 50. The 1 comes down, so that gives us a minus 50. The derivative of x is 1. So that's what it is. We could leave it like that. You'll see I think they simplified it just from the peak we had because this negative exponent goes down. So we can write this. And notice the 1/2, the 2 is down in the denominator. This will be down in the denominator. Another way to write this is 3x squared minus 50 over 2. We could take this back into a square root if we want. I'm not sure if they did that or not. To the third, because nothing happens to the inside. Let me just clean that up a little bit. X to the third. Okay, and I think that is what they did on the peak. So that's how they got it, though. Derivative of the outside times the derivative of the inside. Okay, a couple more examples, and then we'll move on to the next section. Okay, so here again is really a simple thing. You can see the parentheses determine an inside function, and on the outside it's something to the 4/3 power. So when we take its derivative, we just take the exponent to the front, 4/3, 6x plus 1, that just doesn't change. That's what it is. Now 4/3, when we take 4/3 and we subtract 1 from it, subtract 3 over 3, right? Common denominator. So that's going to give us 4 minus 3 is 1/3. Okay, so that's now to the 1/3 power. That's how we take that derivative. The only thing left to do is to take the derivative of the inside part. So what's the derivative of 6x plus 1? Well, the derivative of 6x is just 6, because the derivative of x is 1. Derivative of 1 is 0, so that's all there is to it. And there we have it. We can simplify it a little because we could take 6 divided by 3, bring it over here if you want. 6 divided by 3 is 2. So what we're really doing is we're just taking 4/3 times 6. So if you want, it's 24 over 3, and then reduce it. I like to reduce it here. 3 goes into 6 2 times. 4 times 2 is 8. Okay, so our final answer here will be 8 times 6x plus 1 to the 1/3. Okay. For this one, what we're going to do is we're going to rewrite this. We're going to rewrite this with a negative exponent because that's the best way to deal with things, I think. So it comes up to the top. We're going to have 25 times the expression x squared plus x plus 2 raised to the negative 4 power. So when we go to take the derivative of y, the negative 4 comes down and multiplies times 25. 4 times 25 is 100. I'll go ahead and write it out just because, if you're just looking at the the written version, it's there. So that's that exponent coming down and multiplying. X squared plus x plus 2, that's the inside part, all good. Subtract 1 from the exponent. Well, since we're going to have another step anyway, why don't I just show that? And then we multiply by the derivative of the inside part. 2, or x squared gives us 2x. Derivative of x is 1. The exponent comes down, and then subtract 1, that's x to the 0. Derivative of a constant of 2 is 0. Okay, so let's go ahead and give ourselves a little bit more room. This derivative, 25 times 4 is 100. There's a negative on it. This one is going to be x squared plus x plus 2 to the negative 5 power times 2x plus 1. And if you want, you can move this back down to the denominator. It's a valid function as it is. So we've got 100 times 2x plus 1. While you're at it, if you want, you could distribute it. Again, not absolutely necessary, but 200x minus 100, so taking the negative 100 times that, all over x squared plus x plus 2 to the 5th power. I'm just a little curious, so I'm going to pop down and let's see if I can, I've got the answers here. So that's what we had for the first one, right? You remember that one. And yeah, they didn't distribute the 100, but why not, whatever you like. They got the negative out front, but they do have that negative. Okay. So let's come to this last one here, and that will get us for the chain rule. Okay, so we take the derivative of y. So what we do is we take the derivative of e to a power. Okay, and where the inside is really up in the exponent itself is the inside part. So remember, e to the x, or say e to the u, when you take that derivative, it's e to the u. Again, with the chain rule times the derivative of u. We'll use this sometimes. So this is just going to be 8e to the minus 2x times the derivative of the inside, the derivative of the exponent. Derivative of negative 2x is negative 2. Right? So u, in this case, was equal to negative 2x. So when you take the derivative of u, you get negative 2. Okay. So then we can actually multiply. 8 times 2 is 16, so we got a negative 16 in the front, e to the minus 2x. Okay, don't subtract 1 from this exponent up here. That's not how we take the derivative of exponentials, only of polynomials with constant exponents. Okay, so there's her. There it is. And then I think, let's see, yeah, we get into the next section. So I'm going to stop this video here, post it separately, and then make the next section. Thanks.